In section 4.1, we're going to take a look at factors. First off, what is a factor? What is a divisor? If we take a look at our multiplication problem, A times B equaling C, and then the division problem that goes along with that, that division problem would be C divided by A is equal to B. We know that in our multiplication, A and B are called factors. They're two numbers that multiply to give us a product. We can see that in the division problem we have here, that when we take C divided by A is called the divisor. And the reason for that is because A is a factor. So we can go back and forth between the multiplication equation and the division equation and see that A is both a factor and a divisor. So factors and divisors are just two numbers that multiply together to give us a product. If we look at the definition, if A and B are whole numbers with A not equal to 0, then A is a factor or divisor of B and can be written as A horizontal line B if and only if there is a whole number C such that A times C equals B. So we can call A a factor or divisor if we can multiply it by another number to give us the product we were looking for. So if we look at example 1, 7 is a factor of 35. If we use that definition, can we write 7 times some number C to give us 35? And we can. We know that 7 times 5 gives us 35. So because of that, we can say that 7 is a factor of 35. If we look at the next problem, 5 is a factor of 24. Can we rewrite it so that we can say 5 times some number gives us 24? In this particular case, we'd see that there's no whole number that we can multiply 5 by to give us 24. So we would write out that 5 is not a factor of 24. So it's that horizontal line with a line through it. In the early grades, when we talk about factors, we can use manipulatives blocks, or we could use graph paper to help us find factors. And multiplication is really based on an area model. So we can give students blocks and ask them to arrange them into rectangles. So if students were given 8 blocks, they could arrange it into a variety of different rectangles. A 1 by 8 rectangle, a 2 by 4 rectangle, a 4 by 2 rectangle, and then an 8 by 1 rectangle. So we have 4 different arrangements. We will talk about how the 2 by 4 and the 4 by 2 are really the same thing. We can do the same thing with blocks to find the factors of 24. Here you can see we have a 1 by 24 and then a 24 by 1. We have a 2 by 12 and a 12 by 2. We have a 3 by 8 and then an 8 by 3. And we have a 4 by 6 and a 6 by 4. So we have all of those different ways of writing out 24. One of the things we'll work on in or a focus of 3rd and 4th grade is listing out the factors of particular numbers. So one way we can do that is we can use the blocks like we did here, or we could use graph paper. Another way to list out factors is using something called a factor rainbow. And the way that this works out is we're going to list out the factors of 18, and we can color code it, or we don't have to, but we're going to link the factors together so that we know we're hitting all of them. So if we start off first with 1 and 18, I'm going to link those two together. And then I'm going to go to my next number. So I'm going to try 2. I know that 2 times 9 will give me 18. And then I'm going to go to my next number, 3. I know that 3 times 6 will give me 18. And then if I go to 4 times, there's no number I can multiply 4 by to get me to make it a factor of 18. And I can try 5. What's nice about this rainbow method is it allows you to get closer and closer between two numbers, and then you can check what's left. So here all I had to check were 4 and 5. So let's try another one. We want to list out the factors of 30. To list out the factors of 30, again, I'm going to start off with 1 and 30. And then I'm going to move to 2. I know I can do 2 and 15. And then I'm going to go to 3. 3 times 10 is 30. I can try 4. I know that 4 is not going to work for me, so I can go to 5. I know 5 times 6 will give me 30. And then there's no whole number between 5 and 6, so I know I've listed all my factors. So my factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30, but then I also have them paired up. Once we list out all of our factors, we can classify numbers into 3 classifications: perfect, abundant, or deficient. A perfect number is a number the sum of its factors, not including the number itself, is equal to the number. So we have that the sum of its factors is equal to the number. So if we look at the number 6 here, we're not going to include 6, but if we look at the factors of 6, 1 times 6, 2 times 3, and we add up the factors that aren't the number, 1 plus 2 plus 3, we see that that sum is 6. So 6 is a perfect number. We also have another smaller perfect number, and that number is 28. If we list out the factors of 28, we would have a rainbow here. We'd have 1 and 28. We would have 2 and 14. 3 is not a factor, but 4 is. We'd have 4 and 7. So then if we were to add up the factors that we have here, which would be our 1, 2, 4, 7, 14, and not the 28. If we were to add those up, we have 14 and 7 is 21, plus 4 is 25, 26, 27, 28. So we see that those factors add up to 28. Perfect number. There's only 2 perfect numbers less than 100, and that is 6 and 28. A number is considered to be abundant or classified as abundant if the sum of its factors is larger than the number. So it's abundant if the sum is larger. So here if we look at the number 24, we listed out its factors: 1, 2, 3, 4, 6, 8, 12, 24. We're not going to include 24, but if we were to add up our totals, we have 20, 30, 6. So the sum of those factors is bigger than the number that I was starting with, the 24. If I look at 18, I have the factors 1, 2, 3, 6, 9, and 18. I'm not going to include the 18. 9 plus 6 is 15, plus 5 more is 20, so I have 21 here. A number is considered deficient if its sum of its factors is smaller than the number. So if we look here at 10, we're going to cross out 10. We're going to look at 1, 2, and 5. When I add those up, I get 8. 8 is smaller than 10. For 35, I have the factors 1, 5, 7, and 35. I'm not going to count 35. If I add up the factors, I get 13. 13 is smaller than 35. So we can continue on practicing that and classifying the numbers below as abundant, deficient, or perfect. I'm just going to do one for you, and then you'll have a couple practice ones in the Nearpod. But let's take a look at 32. If we look at the factors of 32, I know that I have 1 and 32. I have 2 and 16. 3 is not a factor, but I do have 4 and 8. And then I would check 5, 6, and 7. They're not factors. So now my next step is to go ahead and add up the factors not 32. If I take 8 and 16, that's 24, 28, 29, 30, 31. So I get a 31. 31 is less than, so I would say that 32 is deficient. So we have 2 theorems in this section. One theorem deals with divisibility of the sum, and another deals with divisibility of the product. If we take a look at the first theorem here, this theorem tells us that if A is a factor of B, and A is also a factor of C, then we know that A will be a factor of the sum of those 2 numbers. The example we have is that 4 is a factor of 16, because 4 times 4 is 16, and 4 is a factor of 24, because 4 times 6 is 24. Then we can say that 4 is a factor of 16 plus 24, and we know that 16 plus 24 is 40, so we could also say that 4 is a factor of 40, which is 4 times 10. So the second theorem tells us that we can take a look at A again being a factor. A is a factor of B. Then we know that we can also say that A is a factor of B times any number C. In the example here, we have 5 as a factor of 25, because 5 times 5 is 25. But then we also know that 5 is a factor of 25 times 7. So we could also say that 5 is a factor of 175. And you'll get a little bit of practice working with these theorems in the Nearpod that you will complete after this. Moving on to section 4.2, we're going to talk about divisibility involving multiples. So we talked about factors, and we said a factor was 2 numbers that work together to make us a product. Next we're going to look at multiples, and basically what a multiple is we take a number, a starting number, and we multiply it by whole numbers. So our multiple would be a factor that's being multiplied by a different number each time. So there is a relationship there, but there is a difference. So we have our definition here of a multiple, and a multiple, the definition of multiple, a number B is a multiple of A if and only if A is a factor of B. So if we look at an example up here, we have 20 is a multiple of 5 because 5 times 4 equals 20, because 5 is a factor. So in number 3, we need to determine whether something is a factor or a multiple. So if we look at this first one, it says 9 is a blank of 54. So a factor is if we can take 9 times a number to give us 54, we know that it's a factor. And so here I know that 9 times 6 is 54, so I would say that this here is a factor. In B it says 15 is a blank of 5, so 15 is bigger than 5, so I know that if I multiply by 5 by 3 I can get 15, so I'm going to call 15 a multiple of 5. 49 is bigger than 7, so I know that 7 times the number will give me 49, so I could say that 49 is a multiple of 7. If I listed out my multiples of 7, I would have 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, 7 times 6, 7 times 7, and it keeps on going. So I could see that 49 is in that listing of multiples. The next 2 are a little bit tricky. So we have 4x is a blank of x, when x is a whole number. 4x, 4 times x, is really bigger than x, so I'm going to say that this is a multiple. And we could think of it this way: if we were listing out the multiples of x, we would have x times 1, x times 2, x times 3, x times 4, and so on. So it would be a multiple. In E, it says 4 is a blank of 4x. So I know that to get 4x, I'm taking 4 times my x value. I should write it like this. 4 times my x value. So that means 4 is a factor. It works together to make my result. So every counting number has an infinite set of either factors or multiples. Well, we know that we have limited numbers of factors. We listed out the factors for 6. We saw 1, 2, 3, and 6. So there was a finite number of factors. But when we talk about multiples, we see that dot, 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 meaning they go on forever. So we can say that every counting number has an infinite set of multiples. Our set of factors would be finite for a particular number. So the next thing that this section focuses on is the divisibility rules. And so this is kind of cool because you learn a bunch of rules as to how to determine whether a number is a factor or not, or whether it's a divisor or not. And a lot of these things you're probably familiar with, but there's a couple of new ones out there that you might have not been familiar with. So if we look at the divisibility rules for 2, 5, and 10, what we want to look at is the ones digit. A whole number is divisible by 2 if the ones digit is, well, we know that. We know that a number is divisible by 2 if the ones digit is an even number. So if we end with an even number, we know that our number is divisible by 2. A whole number is divisible by 5 if the ones digit is, so anytime we look at our multiples of 5, we would notice that they either end with a 5 or a 0. So if our ones digit is a 5 or a 0, we know it's divisible by 5. And then a whole number that's divisible by 10, those are our multiples of 10, they're always going to end with a 0 or have a ones digit of 0. So we know that a number is divisible by 2 if it's even. We know it's divisible by 5 if it ends with a 5 or a 0. And we know that it is divisible by 10 if it ends with a 0. So in these practice problems, we want to determine whether or not, what our number is divisible by. So this first number, we have 4,265,324. All we care about is this last digit. This last digit is a 4. It's even, so we know it's divisible by 2. It's not divisible by 5 because it doesn't end in a 5 or a 0, and it's not divisible by 10 because it doesn't end with a 0. If we look at B, 115,240, we're going to look at that ones place. It ends with a 0, so we know that it's even, so it's divisible by 2. We satisfied the rule here, 5, it's divisible by 5, it ends with a 5 or a 0, so we know that it's divisible by 5. And then it ends with a 0, so we know it's divisible by 10. So this particular number is divisible by 2, 5, and 10. If we look at letter C, we have the number 5,285. Its one digit is a 5, so it's not even, but we do see that it ends with a 5, which means it's divisible by 5. But it's not divisible by 10. The rules we have for divisibility of by 3 and 9 deal with adding up all the digits. So if we look at divisible by 3, if the sum of its digits is divisible by 3 as well. And a whole number is divisible by 9 if the sum of its digits are divisible by 9. So if we look at the numbers here in the practice, we need to add up the digits to determine whether they're divisible by 3 or 9 or both. So in the number 12,234, if I add up my digits, I have 7 plus 5, which is 12. So if I look at the number 12, I want to figure out, is 12 divisible by 3? Yeah. 12 divided by 3 is 4. but it's not divisible by 9. I do notice, though, that my last number is even, so I can say that this here is divisible by 2 and it's divisible by 3. In B, I'm going to look at the number 563,742. I want to add up those digits, so I have 6 plus 7 is 13, plus 3 more is 16, plus 6 more is 22, plus 5 more is 27. So for this number here, I know that 27 is divisible by 3, 3 times 9, and it's divisible by 9. So this number here is divisible by 3, it's divisible by 9, and if I look at my ones place, it's an even number, so I can throw in that it's divisible by 2 as well. All right, if I look at the number 613,485 and I want to add up my digits, I have 6 plus 1 is 7, plus 3 is 10. 10 plus 12 is 22. 22 plus 5 more puts me again at 27. So I know that 27 is divisible by 3, it's divisible by 9. If I look at my ones place, I can see that it's divisible by 5 as well. All right, the rule for divisibility by 4 is we're going to look at just the last 2 digits. So the last 2 digits of a whole number, if those last 2 digits is divisible by 4, then the number is divisible by 4. So if we look at 6,716, if I look at my last 2 digits there, I can see that I have 16, and 16 is divisible by 4, so I know my answer is divisible by 4. I also can see if I look at that last digit, it's even, so I know it's divisible by 2. If I was to add up my digits, I have 13, 14, plus 6 more is going to put me at 20. So not divisible by 3, not divisible by 9. So I just have 4 and 2 here. If I move on to 34,564, I'm going to look at those last 2 digits. 64 is divisible by 4. 4 times 16 will give me 64. So my answer is divisible by 4. The last digit is even, so it's divisible by 2. If I was to add up my digits, I have 10 plus 9 is 19, 22. I have 22 as the sum of the digits. That's not divisible by 3 or 9, so I'm just going to leave this as 4 and 2. For C, if I look at 305,219, I'm going to look at my last 2 digits, 19. Is 19 divisible by 4? No. So this number is not divisible by 4. If I look at my last digit, it's odd, so it's not divisible by 2. If I add up my digits, I have 10, 12, 17, 18, 19, 20. I have 20 as my sum. 20 is not divisible by 3, and it's not divisible by 9. So right now I don't have any factors listed from the ones that I checked. 1, 2, 5, 3, 9, and 4. All right, and then we have our divisibility rule for 6. Our divisibility rule for 6 is that a number is divisible by 6 if it's divisible by 2 and divisible by 3. So if we look at our practice problems here, we're going to add up our digits. I have 5 plus 7 is 12. 3 times 4 is 12, so I know my answer here is divisible by 3. It's not divisible by 9. If I look at my last digit, it's odd, so it's not divisible by 2. Not divisible by 5, not divisible by 10. My last 2 digits are 43, that's not divisible by 4. So right now I have 2,343 is divisible by 3. If I go on to 45,612, I want to add up my digits, so I have 9, 10, 18. 18 is divisible by 3, 3 times 6. It's divisible by 9, 9 times 2. If I look at my last 2 digits, I have 12, and that is divisible by 4. My last digit is even, so it's divisible by 2. And because my number is divisible by 3 and divisible by 2, it also will be divisible by 6, using this rule we have right here. All right, our last number here is 141,231,432. I want to check for divisibility here. The first thing that I'm going to do is I'm going to add up my digits. So I have 5 plus 5 is 10, 11, 12, 12 plus 7 is 19, 20, 21. So the sum of my digits is 21. 21 is divisible by 3, 3 times 7. It's not divisible by 9. If I look at my last digit, it's even, so it's divisible by 2. Because I'm divisible by 3 and divisible by 2, my answer is also divisible by 6. If I look at my last two digits, 32, I can see that my number is divisible by 4 as well. It's not divisible by 10 or 5 because it doesn't end in a 0 or a 5. So I have the number 141,231,432 is divisible by 3, 2, 6, and 4. Now you can go back to Moodle and locate the Nearpod that will have you practicing some of the information we did with factors and some practice with divisibility using these rules here.